Section 9.1.1, we're learning about arithmetic series. We started off the school year learning about arithmetic sequences. So this is going to be a little bit different, but it builds on arithmetic sequences. So let's see how. Quick review of sequences. An arithmetic sequence is a sequence in which each term is equal to the previous term plus a constant, meaning we're adding the same number every time. So with an arithmetic sequence, we learned a couple formulas, you'll remember. A recursive formula that says u sub n equals u sub n minus 1 plus d. You'll remember that the recursive formula really just tells you what the pattern is in the sequence. So to find any term of the sequence, u sub n, we take the term before it, u sub n minus 1, and we add on the common difference. Then the explicit formulas we use whenever we want to find an explicit term or a specific term without having to find all the terms before it. So in this case, we have two options with these formulas. We have u sub n equals u sub 1 plus n minus 1 times d. And then we have u sub n equals u sub 0 plus nd. Obviously, the top formula uses the first term, u sub 1, and the bottom formula uses the initial term, u sub 0. Okay, now let's get into talking about series. A series. The indicated sum of terms of a sequence is a series. The sum of the first n terms in a sequence is represented by s sub n. You can calculate s sub n by adding the terms u sub 1 plus u sub 2 plus u sub 3 all the way through u sub n. The sum of any finite or limited number of terms is called a partial sum of the series. Sigma notation can also be used to represent a partial sum. So we already introduced s sub n. Now we're introducing sigma. Sigma is a Greek letter that stands for the sum. Now, whenever we're given a series in sigma notation, you're always going to have on the bottom n equals some number. That number is where you start. And on the top, you're always going to have another number. That number tells you where to stop. You'll see this in some examples coming up shortly. Now, in front of the sigma, you will always have a formula. Now, this formula could be the recursive formula of a sequence, or it could be a formula that you're going to plug into. And again, you'll see this play out in some examples. So in this example, we're given some information right off the bat. We are told that u sub 1 equals 7. So we know that means the first term of the sequence is 7. We're also given the recursive formula of the sequence. U sub n equals u sub n minus 1 plus 2. This recursive formula simply tells us that to find the next terms of the sequence, we're going to keep adding to them. It says list the first 7 terms of this arithmetic sequence. Okay, so let's do that. We know the first term is 7. To get the next term, we're going to add on 2. So we have 9, then we add 2 again and get 11, then 13, 15, and 17, that's 6 terms, 19, What are the first 7 terms of that sequence? Now the next 3 questions here at the bottom are all series questions. The first question says, find S sub 3. Well, S sub 3 means add up the first 3 terms of the sequence. So we're going to add 7 plus 9 plus 11. 7 plus 9 is 16. 16 plus 11 is 27. So S sub 3 equals 27. All right, the second part says find S sub 5. So S sub 5 means find the sum of the first 5 terms. So we would do 7 plus 9 plus 11 plus 13 plus 15. So S sub 5 equals 55. So to find S sub 7, that means add up the first 7 terms of the sequence. So when we add them up, we find that S sub 7 equals 91. Alright, here's our second example. Again, we're given some information right off the bat. We are told that the first term of the sequence is 12, and that the recursive formula u sub n equals u sub n minus 1 minus 4 tells us that to find the next terms of the sequence, we're going to subtract 4 each time. List the first 6 terms of this arithmetic sequence. Okay, so we know the first term is 12. So we're going to subtract 4, and we're going to get 8. Then subtract 4 again and get 4. Then subtract 4 and get 0. Then subtract 4 and get negative 4. We need one more term here. Subtract 4 again and get negative 8. Alright, now we move on to the series questions. And you see that these questions include the sigma notation. So the first one that we have here, it says find the sum from n equals 1 to 4 of u sub n. Okay, so what this means is we're going to start at the first term, and we're going to add up through the 4th term. The terms of the sequence of u sub n, which we were given above, right? Okay, so here we go. Alright, so we have 12 plus 8 plus 4 plus 0. So the sum of the first 4 terms of u sub n equals 24. The second one says find the sum of the first 6 terms of u sub n. So we would add up the first 6 terms. 12 plus 8 plus 4 plus 0 plus negative 4 plus negative 8. So the notation of S sub n and sigma mean the exact same thing, they're just written differently. All the math is addition, but you have to understand the notation. Alright, here's another example, slightly different. Because you'll notice here we're not being given u sub 1, we're not being given a recursive formula, but we are being asked to find the sum of the first 5 terms of the formula n plus 7. So we have to find the first 5 terms before we can actually add them up. So we're going to plug in 1 for n. 1 plus 7 is 8. And then we're going to add on the second term. So we plug in 2 for n. 2 plus 7 is 9. Then we're going to add on 3 plus 7, which is 10. Then we're going to add on 4 plus 7, which is 11. Then we're going to add on 5 plus 7 is 12. So the sum of the first 5 terms here is 50. So here's another example. Same setup. You'll notice the formula is a little more complicated. It's actually a quadratic, right? N squared minus 3. But the process is all going to be the same. So we're going to start by plugging in 1 for n. 1 squared is 1, minus 3 is negative 2. And we're going to add on, plug in 2 for n. 2 squared is 4, 4 minus 3 is 1. And we're going to add on, plug 3 in for n. 3 squared is 9, 9 minus 3 is 6. They want us to stop right there because there's a 3 up there, so don't go any further than that. And now we can add these together. Negative 2 plus 1 is negative 1. Negative 1 plus 6 is 5.
Sorry.
So this is our last example. It looks very similar to the setup of the previous two using sigma, giving us the formula n minus 5. But notice where this one starts. It doesn't start at n equals 1. It starts at n equals 0. The process doesn't change. We're still just going to plug in the different values for n. So we'll start by plugging in 0 for n. 0 minus 5 is negative 5. And we're going to add on, plug in 1 for n. 1 minus 5 is negative 4. Then we're going to add on, plug in 2 for n. 2 minus 5 is negative 3. Plug in 3 for n. 3 minus 5 is negative 2. And then finally, we're going to end up by plugging in 4 for n. 4 minus 5 is negative 1. So the sum of the first 5 terms, starting from the initial term, is negative 15.